And welcome to today's DevOps.com workshop, brought to you by Techstrong, AWS, and Weaveworks. My name is Cody J. Brown. I'm the host of Techstrong Learning. We have an exciting presentation ahead of us, but before we begin, I have just a couple of housekeeping notes. First, today's workshop is being recorded, so if you miss any of today's discussion, or you'd like to rewatch or just participate with the workshop at a later point in time, sorry, I'm getting a little bit of feedback. One moment. My apologies. Sorry, everyone. So if you have any questions for our speakers today, we want you to direct those to the Q&A tab on the right side of your screen. And we also want you to use the chat tab so that you can converse with the rest of your fellow audience members, or just let us know if you have any other thoughts that will influence the conversation for today. Finally, at the conclusion of our webinar, we will be giving away 4 $25 Amazon gift cards, so be sure to stick around. So our topic today is simplifying hybrid cloud Kubernetes with AWS, EKS, and Weaveworks. And I'm joined today by Leo Murillo, Principal Solutions Architect at Weaveworks, and Zohaib Khawaja, Partner Solutions Architect at AWS. It is my pleasure to turn the floor over to Leo and Zohaib to get us started. Thank you both so much for being here with us.
Thank you, Cody. Hey, so I guess just a quick intro. Thanks everybody for joining us today, and thanks Zohaib for being here. We're going to start with getting you. Actually, Zohaib, I guess we should start with the deck, and then you go over the instructions on how to join Event Engine afterwards, right?
Yeah, I think that's best.
All right, cool. So Cody, we're going to start over with a presentation. So I'm already sharing my screen. All right, there we go. All right, well, again, thanks everybody for joining. This is very exciting. We're very happy for you all to be here, and that we can talk about hybrid Kubernetes. All right. A little bit about myself. As Cody mentioned, my name is Leonardo Murillo. Everybody calls me Leo. I'm Principal Partner Solutions Architect at Weaveworks. But I've been in this industry for a long time, from the kind of co-location facilities, and even before that, kind of like BBS times. So I've seen a lot of things, and I've worked with companies all over the world of different sizes. Right now, I'm focused on helping organizations deliver value to users using Kubernetes at scale. All right. So what we're going to be talking about today is this. So let me kind of walk you a little bit as to what the whole flow is going to look like. We're going to go over this presentation where we're going to talk about these things: Git Ops Principles, how GitOps helps us in increasing the reliability of Kubernetes clusters, and kind of recovering clusters in case of disasters, and applying this at scale on hybrid environments, right? Where you have using multiple clouds, where you have infrastructure on premise. And we're going to look at EKS as the foundation of this hybrid architecture. And then we're going to jump into a workshop. At that point, Zohaib is going to show you how to log into a kind of temporary AWS account that you're going to be able to use on your own to follow the different steps of this workshop. And then we're going to have Q&A. We're going to have 2 segments of Q&A over time. One kind of like in the middle of the workshop as we're doing things that take some time. I really want everybody to take the opportunity to kind of be open and ask questions. There is a comment section that you'll be able to use, as well as a Q&A, I believe, where you'll be able to pose your questions. All right, so this is what we're going to be talking about today. What is GitOps, and how to use GitOps and EKS to simplify the management, to improve the reliability, and to have proper governance and visibility of your Kubernetes clusters running EKS, no matter where they're running, whether in the cloud, on-premise, or anywhere else. Okay? All right, so let's talk about the GitOps principles. GitOps is a term that was coined by Weaveworks, I believe, back in 2017. And when everybody started to learn about GitOps, it took traction, right? People started to really see the benefits, see the value. But pretty much the same thing that happened to DevOps, right? Everybody got really excited. Everybody wanted to do DevOps. And all of a sudden, DevOps started to mean different things to different people. And whoever you asked what DevOps is and how do you do DevOps, everybody came up with a bit of a different story. So because of that, various companies, Red Hat, Microsoft, Weaveworks, CodeFresh, and some others that I can't recall right now, decided through the Cloud Native Computing Foundation to start a working group to have basically a community-driven definition of what GitOps really is all about. Like, what is GitOps and how do you do GitOps? Through the GitOps working group, a project was started, which is called the Open GitOps Project. And one of the first artifacts that the Open GitOps Project produced was the GitOps Principles. So I want to talk about these 4 principles so we understand how GitOps works, and that it's not just about having Git or infrastructure as code, that there's something more to it, okay? There's 4 principles. The first principle is that a system managed by GitOps must have its desired state expressed declaratively. So let's highlight a few things here. First of all, we're talking about a full system. This is a paradigm, this is a pattern that does not just apply to applications or to infrastructure. It applies to all the different levels of a stack that represents a full functional system. It's about infrastructure and applications together. And the way that you declare it is, well, declaratively. You're expressing how you want it to look. Now, this is very important because there's a key difference between declarative configuration and kind of like the traditional way CI/CD has been done, that is imperative. With declarative configuration, you're only describing how you want your system to operate, how you want your system to look, okay? You're not providing any specific instructions to a target environment for it to reach that desired state, okay? So it's a description, not an action, not an instruction, okay? The second principle is that this desired state that you're declaring, where you're describing how your system looks like, it doesn't change, it evolves, okay? Every time you introduce a change to your desired state, you're effectively creating a new version of that state. Now, everybody that does software development is already quite familiar with this, right? This is kind of like versioning. And if you've been using containers, we're also talking about immutability. They don't change. Once you have a hash, it's unique and it doesn't change. And the idea is that this desired state that is stored immutably and versioned is stored in a system that can guarantee that. And I don't know if you guys are, if your folks are hearing this, but I have like a massive storm happening outside. So if you're getting a little background noise because of all the rain, I apologize. And please, if you are, let me know, and I'll try my best to be heard, okay? So version and immutable. That's the reason why Git became such an kind of like natural repository to store our desired state. It's versioned. Basically every change introduces a new version. Every version is hashed, and you have a complete audit log of everything that has happened over time to your desired state, okay? Principle number 3 is that it's pulled automatically, okay? There's agents running in your target environment. There's agents running in your cluster that are continuously pulling this desired state from its source, okay? So this is basically not event-driven push-based. There is not an action that triggers an event from the outside of the cluster that pushes the state into the cluster. The agents in the cluster are continuously pulling this description of how the system should look like, and they do that automatically. And one of the key elements that I think is very relevant to GitOps is that these very same agents that are always pulling that desired state are abstracting the complexity of the different actions that need to happen for the runtime of that environment to match that which you have described. And this is happening continuously. There's a continuous process introspecting the state of the target environment, the state of the cluster, and comparing it to that which you've declared in your code. And this continuous process guarantees that there's going to be a state of reconciliation between your desire and the actual runtime. Okay, so these are the 4 principles that now have been defined as version 1.0 of the GitOps principle by the Open GitOps community. Okay, so I represent Weaveworks. We have a product called Weave GitOps. So I'd like to talk to you as to how Weave GitOps, and we're actually going to be using Weave GitOps today, applies these principles in action. Okay, Weave GitOps runs in Kubernetes, and Kubernetes is a very natural target for GitOps operations because of how it is configured, right? Kubernetes has an API, and what you push to that API are manifests. So we're using those Kubernetes manifests as declarative configuration. Those manifests are not explaining to the target system how to get things done. They're just declaring, describing the spec, the characteristics of how we want the target system to run. So declarative configuration. They're stored in Git, which means every change produces a new version, which is immutable. Okay, so we have version and immutable desired state. And the actual process of getting that desired state into the cluster happens by agents. With GitOps runs agents in the cluster that are constantly pulling from this Git repo, introspecting, observing the state of the runtime, the state of your Kubernetes cluster, and reconciling it with this described configuration. So this is why with GitOps does apply and how it does apply all these different GitOps principles very purely. Okay, it's actually very, very close to it's the definition of how GitOps should work. Okay. Now, what's very interesting, and here we start looking at the value of this in hybrid environments, is that as I mentioned closer to the beginning, this is a pattern that applies to a full system, not just applications, not just infrastructure. The same pattern applies for everything. And what we're going to be actually trying out on our own today is how we can actually create and operate multiple clusters from a single management cluster using declarative configuration and continuous reconciliation by Weave GitOps. And these leaf clusters, as we call them within kind of the Weave GitOps world, they can run EKS, and they can run EKS everywhere. Okay, they can create EKS clusters in AWS. They can use EKS distro to run clusters on a number of infrastructure providers or even on-prem. Okay, so how do you go about that, right? How does it? How do you declare an EKS cluster? What we're going to be using today for declaring our clusters is called Cluster API. Okay, Cluster API is open source, it's community driven, and basically it gives you a framework that also using Kubernetes controllers and using Kubernetes manifests, you can describe, you can declare what you want your clusters to look like, as well as where you want those clusters provisioned, as where you want those clusters deployed. The real important value above Cluster API, and kind of like one of the key decisions in terms of design that I think makes it so effective for hybrid architectures, is the boundary that it creates between the concept of cluster and the concept of provider, right? The fact that you can provide, that you can describe a cluster, meaning what's the network CIDR that you want to use for your cluster network, any other characteristic of how the actual configuration of the cluster itself, Kubernetes itself, will look like, is separated, is decoupled from the actual provider that is going to take whatever actions necessary to create and provision that cluster. Okay, so the cluster is generically applicable. It's one cluster configuration that you can apply to one or more providers. and the provisioning of those clusters actually happen abstracted away from you. You don't have to worry about the specifics of how a given provider is creating those clusters, all the different actions and all the different resources that are necessary for the cluster to be created. So what's the value to hybrid? Well, first of all, you can declare your clusters once. You can apply them to many, many different places. You don't have to worry about the complexity of what it needs for you to actually provision that cluster in a given target environment. You could be using multiple clouds. You could be using AWS and other hyperscalers. You could be running bare metal on Equinix. You could be running hosts on bare metal in your data center. There's going to be a different provider for each one of those different underlying infrastructure providers, right? That are going to take on the responsibility of doing whatever they need to do to provision that cluster. All right. So there, I hope you can start seeing the value to simplifying the creation and management of clusters across hybrid and multi-cloud architectures. So there is simplification, which is great, but there's more value just beyond simpler operations. Although there's already a lot of value there, but there's more to it. Okay. The larger that your platform becomes, the more clusters that you operate, the more environments that you have, the harder it becomes to operate them, to keep them reliable. Okay, and we have seen a kind of like tendency, a trend, right, to go from reliability just in terms of availability, right, just that a system is performing as that is available. Because with the introduction of site reliability engineering, and you can start thinking about error budgets and stuff like that, right? You really are looking to guarantee that the user will receive an expected acceptable experience, right? Not just that the system is going to be up, but that it is providing the user with an acceptable experience, even if downtime is unavoidable, right? Even if things are going to go down and if performance is not going to be optimal all the time. So if you want to guarantee that reliability, right, one of the easiest ways to approach it for you as an individual, as an engineer that is trying to implement these different mechanisms to guarantee reliability, as well as in terms of implementation, is automation, right? If you can automate how things get deployed, how things get scaled up and down, and more importantly, how things recover, how components of your system recover, then you have the better odds of making sure that you're not consuming those error budgets too fast, that you can keep them low, okay? And that your mean time to recovery is low, right? Because recovery happens automatically, happens faster than you as a human can do something about. So this is exactly what the continuous reconciliation process of agents do, right? An agent is taking this description of what you know you need to guarantee that your system is reliable. The number of instances that you need to scale from and to, right? The different services that you need to operate. The expectation of availability, of performance of those services when you're doing a canary deployment. All those specifications are declared in code. And there's this agent running in a cluster that is guaranteeing that you're always gonna get that. If something crashes, if something is manually deleted by mistake by some user, that agent is gonna be watching and it's gonna say, the state of my system is inconsistent with what you have declared, and it's gonna fix it for you very fast, okay? So how does this actually look like altogether? We are really looking at two different components of a Kubernetes-based system managed by GitOps here. Kubernetes by itself has a reconciliation loop, right? When you deploy a new deployment object with a certain number of replicas defined, There's a controller that is watching and that is guaranteeing that you're going to get those replicas in place, that you're going to have the number of replicas that you expect. But there's some stuff that falls outside of what that loop is doing all the time. Somebody goes and deletes that deployment by hand, then the controller is no longer going to get your pods up because the deployment doesn't exist, right? This is where Weave GitOps comes into play, right? Weave GitOps is working together with the Kubernetes control loop to make sure that Kubernetes always has what you expect it to have in terms of objects, right? And if things fall outside of that desired state, if there's divergence, then Weave GitOps can do many things. It can do notifications, it can do auditing and policy, it can even write back to Git when things occur that drift away the state of the cluster from that which you know is necessary to keep a reliable system operating, okay? So this also has a very kind of meaningful impact to disaster recovery, because that I'm telling you, there's a storm happening. So there's like it's insane.
I had to make sure it wasn't coming from outside my room. Also, just like there was a question in chat: is Cluster API performing the same function as CloudFormation? Thank you.
Okay, is Cluster API performing the same function as CloudFormation? Not necessarily. Okay, so CloudFormation is infrastructure as code. So there's a code component to it. In CloudFormation, you're defining a template, which could be YAML or JSON, where you have your different resources, etc. And then you're applying that template to AWS, okay? Now, it's an interesting question, because first of all, if there is a deletion of an object manually, and you can keep me true here, Zohaib. If there's a deletion of an object, so if I created my CloudFormation template and I declare an object, whatever, like an S3 bucket, and CloudFormation creates the bucket for me, and then I go back and manually delete that bucket, CloudFormation isn't gonna create it again. No, right? So it happens once. You apply the template, it creates the objects, and it forgets about it. Okay, unless you do all sorts of craziness, right? Like bind events that are thrown by AWS and kind of like rerun the template or whatever, right? So it doesn't have the continuous reconciliation process. It's not introspecting and applying and guaranteeing the state, which is again one of the key elements of GitOps. And this is also relevant to kind of like if you think about Terraform, not just CloudFormation. Terraform, you declare your infrastructure, you do a Terraform apply, it creates your infrastructure, it stores your state, and that's that. If I go and delete everything by hand 2 seconds later, unless I manually run my Terraform again, it will not do it, right? So there's the continuous reconciliation component of it. There's also the automated pull of it, right? CloudFormation doesn't by default pull from a repository. So for example, let's say you store your CloudFormation templates in a Git repo or in an S3 bucket, right? It will not automatically update. It will not automatically run a CloudFormation update if those CloudFormation templates change in the bucket or in the repo, right? It's not continuously watching that. So there's that continuous and automated process, which is exactly the elements that differentiate GitOps from other CI/CD patterns and from other infrastructure as code tooling, okay? So I hope that answered the question or provided some insights, all right? Okay, so GitOps and disaster recovery. Now, we talked about how these agents that are kind of running in the cluster and continuously reconciling are helping in guaranteeing reliability. But this is not just about reliability, right? If you have your entire system declared and version and immutable, And when we say entire system, we're talking about infrastructure and applications and cloud resources and everything else, right? Because now basically you can create anything through the Kubernetes API. Then disaster recovery becomes very much simpler, right? Because it maybe means that you're going to have to change providers to deploy to a different region, right, of the same provider, or you might want to use your cluster declarations to create that same cluster in another infrastructure provider, and your applications are already declared. So you just point it to the repo, and they just come back up to whichever state they were. So it's the disruption. It becomes way smaller, and then the actions that you need to take, if any at all, because it could be fully automated, right? Like if there was a problem, temporary problem in some region that like damaged one of your clusters, the reconciliation loop could just bring it back up for you, right? And then the cluster itself will bring the configuration back from the repo and spin up all the applications again. So there's even the possibility of fully automated disaster recovery, but there's always going to be components that may fall outside of that automation. And GitOps still, or the fact that you're having declarative configuration, makes it a whole lot easier for you to recover, even when you have to perform some manual actions. Okay. And the fact that GitOps is about pulling, right? You're not pushing out, makes it a whole lot easier, right? Because you can control authentication at your source of truth, right? At where you're storing your desired state. Think about the fact, like you have one cluster, it died on you, it crashed, and then you had to bring up a new one. If you were thinking about a push-based mechanism, you would have to, every time there's a thunder, I see Zohaib looking all around, you would have to basically add that new cluster and add that new authentication to the cluster to your pipeline so that you can talk to it. You likely would have to modify your network configuration at the cluster's endpoints to be able to allow connections coming in from whatever is doing your CI/CD. You don't necessarily have to do any of that with GitOps, right? Because the cluster is pulling from Git. So it's an outgoing connection to your Git repo, and you're controlling access from within the Git repo. So it makes it simpler. Now, anybody that has been kind of like doing this for a while is going to ask, so what about data, right? Like what good is it that I can recover my cluster automatically if the data that my applications need to run is not there? Very valid point. And GitOps doesn't save you from that, right? You will still need to follow proper data practices, right? You will need to have backups. You will need to think about your RPO and RTO. You're still gonna need to think about where to keep those replicas, or whether you need synchronous replication or not. Like, you're still gonna have to think about that. So basically, I just want to make sure that everybody understands kind of like the scope, right? Where it has an impact and where it doesn't. Now, what is interesting is that your pipelines that you might have to move that data around, or that the services that you have for data backup may very well be declared in code and described as part of your desired state. So the actual processes that are moving that data around could also benefit from the GitOps principles, the GitOps way of doing things. So because you have a boundary between cluster and underlying provider, it becomes a whole lot easier for you to create consistent environments, right, in terms of configuration while switching providers. It also becomes easier to create highly available architectures, right, because you can easier produce multiple replicas, multiple instances of whatever you need to run your service. And it also becomes easier to scale, right? You can think about scale both in terms of cluster, with cluster autoscaler, and you can think about them in terms of workloads, kind of like with native objects such as deployments and stuff like that. So it's no wonder that Kubernetes is becoming kind of like has become the kind of de facto orchestrator for containerized workloads. All right. Now, we talked about compliance, and one of the principles is that you have version desired state that is immutable. So we already kind of like touched on this. We really take advantage of Git for that. Everything that happens in Git is uniquely hashed, uniquely identified, right, through a hash. Everything is attached or tied to a specific user. And it represents a unique and immutable state at a point in time, right? Git is a timeline with uniquely hashed representations of the code at that specific point in time. Worked already great for application development. Now it's working for everything in the stack. And of course, when you're thinking about compliance and when if you're audited or anything like that, then this type of visibility and this type of guarantee of traceability becomes very, very important. But there's traceability, there's auditability, and there's compliance. So recently, Weaveworks purchased a company called Magalix. Magalix does policy as code, okay? And we've now incorporated Magalix into Weave GitOps. And what you can do now is, because you have also a mechanism by which you can declare your expectations of compliance, basically, which is a policy, right? Not instructions, not check this, check that. This is my policy, this is my compliance, this is what I think should be met. And you have agents running in the target system guaranteeing continuously that this policy that you've described, that this policy that you've declared is continuously met, okay? This is super important in hybrid environments, because in hybrid environments, you likely will not necessarily deploy the same workloads across all your clusters, right? Some clusters are going to be running pre-prod stages, right? So you might have different production environments for different specific use cases, and that's likely reasoning behind you choosing a given hyperscaler or a given type of underlying infrastructure provider, right? Compliance is also about making sure that the workloads that are running in those clusters are the ones that you expect, right? You can do that by signing your container images, for example, and introducing policy that guarantees that only certain signed images can run in certain production environments, right? It helps you make sure that as much as your fleet can grow, as much as your architecture can become complex, you have controls in place that are continuously guaranteed by the clusters themselves to make sure that only the workloads that you anticipate are running in the proper environments, that only the security characteristics that you need to ensure are present are being met, that you have SBOM implemented, that you are not pushing container images with vulnerabilities. All this stuff can be guaranteed, can be validated at runtime by describing that policy. And GitOps continuously will make sure that that's the case. So we're about hybrid EKS, right? So why is this so important for hybrid EKS? Using the technologies that we've spoken about, using Weave GitOps, using Cluster API, using declarative configuration, decoupling the clusters from the underlying providers, we are able to follow a consistent operating model with reduced code complexity, abstracting provisioning logic against pretty much any infrastructure provider out there, okay? And that's a growing list, okay? We're talking that you can deploy across public clouds, that you can deploy across private clouds, that you can deploy with bare metal, and all following the same pattern. You can declare your policies. You can control how and what workloads get distributed across those different environments, all from a single source of truth, all from Git, without having to jump through hoops to talk to the different environments, okay? But we also got to think about kind of like the relevance of EKS within this concept, right? It is very important when you start thinking about running Kubernetes across hybrid environments, you are inevitably gonna be exposed or be confronted by the fact that Kubernetes is not just Kubernetes. It's a distribution of Kubernetes that you're going to be running wherever it is that you need to run Kubernetes. There's a number of distributions, right? There's upstream Kubernetes, which is kind of like the one that's managed by the CNCF. And then there's any number of other distributions that take that upstream and opinionate it, right? Make choices as to what different components they want to use and kind of how those components are configured. And I guess more importantly, how the release of those, how they're going to release, right? How closely they're going to track Kubernetes releases over time, how closely they're going to track patches over time. When are they going to stop supporting something, right? And when you have Kubernetes running across multiple environments, if every one of those environments is using a different Kubernetes distribution, you're gonna run into eventual pain, right? Because some environments might get releases at a different point in time. Some environments might be no longer supported in terms of patches at a certain point in time that others are not. There might have differences in kind of control plane components, right? So you really want to make sure that you're picking, ideally, a distro that works across the board. And this is where EKS distro, I think, really shines. So EKS distro is the Kubernetes distribution that runs managed EKS. So if you spin up an EKS cluster in AWS, you're actually getting EKS distro underneath. But the AWS team actually open sourced that distribution and called it EKS distro. And it's effectively the same EKS distribution that you get when you're running in AWS. And you can run it anywhere. There's builds for ARM that's built for basically any architecture. And this will really simplify your ongoing management of your clusters, right? Because once your clusters are running, it's kind of like just the tip of the iceberg, right? From that point forward, you're going to have to observe, you're going to have to upgrade, you're going to have to patch and secure them. So you want to make sure that you're picking a distribution that really kind of eases your work and simplifies guaranteeing the guarantee of reliability over time of your hybrid architecture. And that's what I think EKS distro is very relevant for hybrid environments. And when you think about delivering workloads to hybrid environments, then you also have to think about other things, right? Like, how are you going to provide development teams with autonomy? How are you going to secure those environments and kind of like promote releases over environments and do advanced delivery patterns? And all these things become a whole lot easier when you are running GitOps and when you're using declarative configuration and running Weave GitOps across all these different target environments. So now I want us to actually run through the motions and create a cluster. Like here's what we're gonna do. We're gonna use an EKS cluster that you're gonna get pre-provisioned. We're gonna install our Weave GitOps agents in that cluster. We're gonna install cluster API. We're gonna create another cluster from that cluster, and we're gonna operate it. We're gonna change its version. We're gonna upgrade it to a newer Kubernetes using nothing but GitOps. So I'm gonna hand it over to Zohaib now, so that you can actually see what you need to do to get into your own little AWS temporary account.
Thanks a ton, Leo. So I'm going to be screen sharing my screen here. Thank you, Young, for posting the link in chat, the dashboard.eventengine.run/login. That'll bring you to this page. We have an event hash specifically for this event. That's also copy and pasted in chat as well. It begins with 6, ends with an A. You copy and paste that into here. And once you accept the terms and logins, it's going AWS provisions resources for temporary AWS accounts for you guys to use. We give it back to you, the people, and then from here, you're going to enter your AWS login. Now, one thing I want to mention you're going to see this over here, this open console or copy link, and it's going to look like a little cloud. I want you to copy these credentials and just store them like in a little notepad to the side. Leo's going to need this in the future for you to use during the workshop. So once you've copied this, once you've copied these credentials, go ahead and open the console. I'll wait, let's say I'll wait 3 minutes total to let everyone in. So it's at 41. I'll wait until 43, 44 to let everyone get in, let it load up. And then from there, we'll go on to the next steps. And it should look like this once you come in. So I'll keep this up to let everyone know what it should look like. I'll be keeping an eye on chat in case there's any questions.
All right, thank you, Zohaib. And yes, please make sure you do copy over that little chunk of code from Mac Linux. That's very important. We're going to need those variables as you move forward. And then just one piece of advice is, I think by default, whenever kind of like you hit open AWS console, it's going to open up in a new tab. Don't close tabs, keep them open just in case you have to go back and kind of like get them from somewhere. It makes it easier. And for anybody that's not familiar, and while we wait, we're going to be using a service called Cloud9. Cloud9 is a web-based IDE that gives you kind of like a web interface to do things. It gives you the terminal, and it gives you kind of like visibility of your file system. So that's what we're going to be using for running through our little motions here. We're actually going to go over. Well, actually, I'll just wait a few minutes, and let's make sure that everybody can get in.
I think you wanted to go see Cloud9. I'm guessing you wanted me to go see Cloud9. I'm just waiting a minute or two, and then I'll show.
Cool. And if anybody has any questions, this time we're idly looking at the screen at the two presenters. Uncomfortable, trying to fill the silence is a good time to ask questions.
Yeah, and I know that there were some questions that were coming through, and Cody thankfully put them in chat. So keep asking questions, and I'll call it in.
Cool.
I'll relay them to Leo.
All right. Please use comments if you have any questions. And thank you, Kevin Tucker, for your comment. Glad you're taking advantage of it.
Okay, so it's at 43. So over here, I want everyone to go to the Cloud9. Actually, I'll do it this way. I'll search for it. It's just simple searching Cloud9. There should be a pre-provisioned cluster for you to use. We're going to open the IDE. This will take a few seconds. In the Preferences tab, once you open up the IDE, there's a bit of a scroll on the left. So when you first open it up, it might look like this. It's just scrolling all the way down to AWS settings. I want you guys to turn this off. Make sure this is a big red X. Once you've done that, I want you guys to go into the terminal and run a bit of script that I'm going to copy and paste in the comments now. Once you've run that, it'll provision all the extra resources that Leo's going to need for his workshop. And then, Leo, you're good to go.
Thank you, Zohaib. I think, so if you copy that over, what Zohaib just pasted on the chat, it's actually going to paste it all in one single line, which is not going to work. So you're actually going to have to copy. Can you send the commands over in independent messages?
Yeah, let me do that.
So we're going to just copy one by one.
I think if you can. Okay. They're in separate lines now. Oh, that didn't work. Okay, let me just do this.
Okay, so I was gonna, each one of those lines is a command. I'm actually gonna do this with you as soon as Zohaib has sent those over. I'm actually gonna share my screen and do it with you all.
Here we go.
All right, sweet. Cody, can you switch over to my screen? Is that it? So oh no, I think there's more stuff that they got to do, right?
No, that's it for us.
That's it?
Here we go.
Okay, cool. All right, so here, as you can see here on my right side of the screen, I have, just as you all should have, hopefully, if anybody has any problems getting here, please do use comments. All right, this is hands-on. I really hope you all can actually do this with me. You'll see the Cloud9 IDE. I'm gonna copy as well in comments this URL. These are the different steps that we're gonna be walking through today, okay? The benefit of doing them with me right now is that you're doing it in an account that's in AWS and that's free of charge. You can also do this on your own, in your own AWS account, but then you're gonna have to have a cluster created beforehand and kind of pay for resources. All right, but it's same thing, okay? All right, so as Zohaib indicated, I'm gonna copy over these different commands. I hope you can see my screen. I've increased the size of my font. If anybody has any trouble seeing, please do let me know. So we're gonna copy over this script. Oh, wait a second, that's wrong. CP, why is it giving me this error? Do you see the error that I'm getting, Zohaib?
Yeah, I think it's requiring paths. Let me see. chmod.
Oh, I probably got to copy it somewhere, right? Okay, so this is the actual command. I'm going to put it, there's a / missing from the command. So this is the first command that you need to run. Okay. And the second command is you're going to make this file that we just downloaded executable, okay, which is the second command that's all you've sent. And we're going to run it. Okay. It's going to do a bunch of stuff. It's going to install a Bitcoin miner in your computer. No, just kidding. This is gonna do all sorts of things just to get your Cloud9 IDE like with all the requirements that you need to do what we're gonna do. I'll take a second.
This part should take probably at most about 2 minutes.
Okay.
Most likely less than that.
All right, fantastic. So there's a bunch of stuff that has just gotten installed. I'm not going to go through kind of everything, but there's a whole bunch of stuff that's been installed that we're going to need through the workshop. We're going to source our profile, okay? So we're ready to get started. Okay, now just before we start, I want you to know what you have in your environment, okay? So you basically in your AWS account, which you've just been given access to, which is temporary account just for you, we have an EKS cluster already. Reason for us doing this is because it takes a little while to get an EKS cluster up, so we wanted to make sure that it was fast enough because we don't have all afternoon, all right? And we have this workshop content that I'm gonna, again, post the link in comments. We're gonna go through these steps, okay? We already have a cluster running. You can move back and forth, so you probably don't have like kind of like this tiny little screen that I have here, and you're gonna see this menu to the left. I'm going to make this bigger so that you all can read. Okay, few things. We are doing GitOps, so we're going to need a Git repo, okay? We're actually not, the process that we're going to go through is actually going to create that repo for you, but we're going to be using GitHub for this, and we're going to need to create a personal access token. So basically, there's this instructions right here on how to create a personal access token. You go to your GitHub account, go to your user and settings, go to, where was it? I believe passwords and authentication. No, where was it? I forgot. Oh, developer settings, personal access tokens, and then you create a new token and you give it, as it says here, granted repo scope. Okay, so you generate a new token. You can name it whatever you want. You can name it workshop or whatever, right? It's a good practice to set it to expire. I actually do recommend you delete it right after this workshop. You can give it no expiration or just have it expired in 7 days, and you give it repo scope. It's going to show you the token on the screen, and you will want to save that. Remember, as Zohaib told you, copy over the, what wasn't that, Event Engine dashboard thing somewhere. This is also something that you're going to want to copy over. So that token that you get, put it together with the rest of the stuff that you saved somewhere. Okay, I already have done that, so I'm going to do it. But create a personal access token. We're going to need that to bootstrap our cluster. Okay, I'm going to give it a minute for everybody to be able to create your GitHub personal access token. And I hope everybody has a GitHub account. If anybody has any problems, please do let me know. The next thing that we're going to run is through these different actions here. Okay, I'm going to actually skip some of this just for your benefit, because I've done this already a few times, so I can give you some shortcuts. Okay, so the first thing that we're going to do is we're going to install Flux. Flux is part of our GitOps toolkit. Okay, so with GitOps, our product actually uses Flux underneath to do GitOps. Okay, so we're going to install Flux. You probably don't, yeah, you need to do this. You need to export your GitHub token as an environment variable. So we're going to do that. Okay, since you pasted it and you stored it somewhere, you're going to take it and you're going to export it to your environment. I'm going to use a token. You'll all see it, but I'm going to delete it right after the workshop, just as I said. No playing around. You export your GitHub token. Okay. Now, you already have an EKS cluster that you should be able to talk to already. It's part of the magic that Zohaib did with his script. So you can actually just do kubectl get nodes, and you should be able to see the nodes of your EKS cluster. Okay. So the first thing that you want to do is bootstrap your cluster against a repo. Okay. So we're going to take this command that you see right here to bootstrap your cluster. Okay. Now do pay attention that you'll need to change this value right here to your GitHub username, because that's where we're going to create the repo. So in my case, it's Murillo Digital. So I'm going to run this command, Flux bootstrap GitHub with me as an owner, and we're going to call this repo workshop DevOps. And this path is the path within the repo where we're going to store the desired state, all the descriptions of our system. Okay. And I'm just, this additional stuff, I'm telling it it's going to be a personal repo, and I'm not going to make it private just because this is a workshop. Okay. I'm going to run this. It's going to connect to GitHub. It's going to create the repo for you. It's going to clone it and basically reconcile it against the cluster. Okay. So at this point in time, your cluster is now represented in a repository, the GitOps components of it. Okay. Matter of fact is, if I do kubectl get all, I'll see now that I have my Flux system running already. Okay. Hey, so why do I have Cluster API running here already? Did it give me the same seat that I had gotten in the past?
Yes, I believe so.
Ah, okay. Okay. All right.
If you want a fresh seat, I can get you one really quick.
No, let's just go through this. And matter of fact, the fact that it's kind of like pre-baked should make it faster. Okay. So now you have a cluster that's bootstrapped. No, you know what? I wonder if there's going to be problems. Let me try. Let me keep going. We'll see. Okay. Now you have a repo that was created by Flux to track your cluster. What that means is that anything that you push to that repository is going to be continuously reconciled within the cluster. Okay, so that repository is your desired state. Okay, and now we have Flux running inside the cluster. Now we need to clone it because, well, we're going to be working doing GitOps, and when we work doing GitOps, what you do is you only work through code. You evolve your desired state by modifying your code. So we're going to clone it. All right. Now we have here workshop DevOps. Okay. This workshop DevOps is the name that we gave to our repository. And as you can see here, I have my workshop DevOps cluster in place. In its path in the repository. Okay. So let's move on to the next step. Let's go into the repo. Okay. Now we're going to install Weave GitOps. Okay. So Weave GitOps is the tool that we use for managing our GitOps state. We're going to need to do a few things. We need to create this Weave GitOps value file. So we're going to create. There's a few things that you can do here. Okay. So one is you can just use the IDE and just create a new file here. But call me old school. I'm gonna do Vim just because I know how to get out of it. So I'm gonna do Vim, and I'm gonna paste this. Wait, didn't copy it. Oh, this is one of the little annoying things of web-based IDEs. Sometimes they don't quite behave as you'd expect. Okay, there we go. Okay, so I have a new file called Weave GitOps values. Now, what this is doing is it's basically providing a username and password configuration to Weave GitOps. Okay, this is not a production-like setting, right? Usually you integrate with some identity provider and stuff like that, but this is just for the workshop. What you end up is with an admin username and password. Okay. Now we're going to use Flux to add a source to this repository. Okay. Now this means that we're going to basically be tracking a Helm repository for changes, because you're going to have multiple sources of truth, right, for different components of your system or for different services. The idea is that you should only have a single source of truth for each element, for each component. It could be one repo, or you could have multiple repos, but each one representing only a component of your system. Okay, so we're gonna create this source. Okay, what this actually did is created a new file, because remember, we're only using GitOps here. So what we actually just created is this manifest. We're saying, hey, I want to track this Helm repository. This is all possible thanks to Flux. And this is the name that I'm going to give it, and this is the path to my repo. Okay. So now I have a new file in my repo, a couple of new files. I'm going to add those. All right. And I'm going to push them over to my cluster. And now, Zohaib, I think this is where we might run into problems, because since I'm pushing new things to a cluster that already has them, maybe this could be a problem. Give me 1 second. Let me. To people that are wondering what the issue is, I already ran through this workshop once before to make sure that everything worked, and I ended up in the same Cloud9 IDE where my existing cluster already had everything in it. So that could be tricky. Okay, so let me actually see something.
Delete and then redo it from scratch.
Just gonna get rid of this.
Okay.
And since it's not in the state, oh, but you know what? This is likely already being tracked from. You know what? I think I'm gonna need a new seat because this is Can you send me a new one?
Yeah. I'll put it in the private chat.
Okay. All right. So, folks, I'm gonna be actually switching over to a new seat. Sorry about that. So that I can start from scratch, just as you. I'm gonna have to rerun some things. It's gonna be pretty fast. 1 second. It's gonna get out of this Zohaib. Just 1 second.
There is a sign-in link for you in the private chat.
Okay. There's a problem with your sign-in token.
Oh. Let me see. Okay, can you go back to the main run page and then put in the same
Hash.
Yeah, the same hash.
Okay, 1 second. Find it. So if anybody had issues getting in, this is what you should do.
So far, everyone's gotten in already. I can see everyone's in their accounts right now.
All right. Okay, just hang in there, fellows and fellows.
Sounds like the story is on.
Okay.
Yes.
So I'm gonna copy this over. I'm gonna go to the console. I'm gonna go to Cloud9. I'm gonna open up my IDE. Nope, same one. Look.
Okay. 1 second.
Now, there's one thing that I want to show you here, which is interesting. While we wait, you see how I had asked to delete the Helm repo from Flux system, and you see how it says that it was deleted, and now I query back and it says that it's still there. That's GitOps. That's the problem, right? This cluster is already tracking another repository where I had done all this. And in that other cluster, there's already a Helm repository manifest in there. It says there should always be a Helm repository called GitOps from this path. And I can't delete it. And I can't create one that's conflicting in name because GitOps. So this is why you get compliance and reliability. So AN is asking, if I miss a requirement, will my cluster die? I'm not sure I understand your question, Ann. Can you elaborate? And while you do that, I'm going to get out of this.
Yeah. If you miss a requirement, I think I'm interpreting the question as, will the cluster itself terminate I don't think the cluster will terminate. I mean, it might be a pretty painful process, but I think missing a requirement would just require you to go back and start from step one. 2 questions: how long will the cluster be left operational? Roughly 13 hours you'll have for any tinkering you want to do. And was a request to Leo, can you please increase the font of the terminal?
I'll do that.
And I'm just give me a couple minutes. New
So please do take advantage of this time to ask any questions. I wonder, Zohaib, if I were to log in and just use a different email.
So that's the unofficial way to do it. It would work, yes.
Let's be renegades. Let's do the unofficial. Hold on a second. Let me get the. Okay. I don't want to.
Yeah, there's a few seats left.
Okay. I'm going to use personal email. All right, let's see. Okay, I'm going to copy this over. Hopefully this is going to be a brand new place for me to work. Go to Cloud9.
No recent services. I think this is a new one.
What was that?
Yeah, I think this is a new one. There was no recently visited services.
Okay. Oh yeah, this is a stopped instance. Yeah, this is definitely a new one. Okay. People, so I've got a new engine running, and this is brand new. Okay. So I hope this helps you see better. Okay, so I'm gonna run the commands real quick again. Oh, I got an error. And I'm gonna full replay even with errors. See, I gotta.
The font's much bigger now. It looks better.
Okay, sweet. Okay. It's gonna take a minute. All right. Okay. Cool. Now we source. Okay, so I've run all the steps that Zohaib put in chat. I already have my personal access token. Gonna install Flux. I'm gonna export my GitHub token. I'm gonna make sure that I can talk to my cluster. Getting an authorized error. Sorry.
One of the previous, there was an error in a previous authorization. I think like 3-4 commands ago. Logged into the server. Can you go back to the main console really quick? Where's your
Where? To here?
Yeah, I just wanted to see which seat it was.
Oh, wait up a second. I think I know what it is.
Oh, the AWS.
Yeah. I think I know what it is. Now, likely, I should be able to talk to it. No, I can't. Let's see if AWS settings.
Yeah.
Okay, it's a big no. But if anybody ran into this issue, okay, say, oh, somebody says that. Alexander Sechenko said that. Okay, so you got to make sure that your AWS managed temporary credentials is off by going into this cogwheel down to AWS and credentials, and then you need to export that which you copied over from the from here.
When you first logged in. Yeah.
I think this should do it. So basically, what this is gonna do is it's gonna remove. Nope. Let me try again. Let's see.
You might have to not restart the cluster. You might have to close this environment, this ID, and then reopen it.
Now here's what I'm gonna do. I'm gonna remove AWS config. Let's see if that does it.
Okay.
No.
Let me see. This is the same. Let me get into one of the seats and try it. In the meantime, do feel free to ask any questions in chat other than this one while we're looking at this. I think I know what the issue is. It'll give me it's like 2-3 minutes.
Okay. Yeah, I think everybody's getting the same error.
Yeah.
You know, when I first ran this on the other event engine, see, I ran into the same problem, and I emailed Young, and he mentioned that there was something else that had to be done. I don't know what that was.
In that case, let me see. Yeah, I think he just had to run the script on specific time. Okay.
So Musa is saying that he would love to do over this workshop. And matter of fact, we might as well. I'll talk to everybody to see if we can schedule another run so that we don't have to pick up your time.
Okay, then it might. I think it requires disconnecting from Cloud9 from this IDE first. Now that you've turned off AWS credentials, and then opening up the IDE again.
And just closing the tab or doing something else?
Oh, just like the tab.
Okay. Tab closed.
And for extra, yeah, and reopening the IDE, connect to it again. Now that the AWS credentials are turned off.
Nope. What's interesting is that I think it's something to do with, because my AWS CLI is actually talking to the API. And okay, let's see.
Yep, I'm able to.
Oh no, but you see, it's actually not using. Look at the identity that I'm using.
Yeah, it's the federated login, but I mean that's really weird. With my seat, I was able. So I took one of the seats available, and I'm able to see the node. And all I did was just the script that I ran. Let me see. Yeah, this is. Can you do me a favor? Can you just the script code from before? Can you run through those? I think it's only 4 of them, or 4 lines.
Which the script that you sent?
Yeah.
Did I download a new version or just run it again?
I just run it again. I think that the script was ran before. My gut instinct is telling me the script was ran before people turned off the AWS credentials, so it needs to be run after the credentials were turned off. That's just my gut instinct, because I picked up one of the seats and it started working when I did it after the credentials were turned off.
Okay, let's see. Oh, you see, it's still giving me this error config map unauthorized. And I think this is effectively what Alexander mentioned, right? For whatever reason, the identity that I'm using is not in the config map of EKS. It's not in the clusters config map for map roles or map users.
So I'm just looking at yours versus mine, adding identity to auth config map. Okay. So it's in JSON. Yeah, okay. Give me like 2 minutes on this. I'm just looking at each account individually.
Okay. And thank you, Alexander, for the help in troubleshooting. Appreciate it.
Hey Leo, quick question. Do you have is there any way I can get you to try a new brush seed? I reserved one for you, one that's working for me.
Sure. Let me go to the same URL. And
sorry, but I'm gonna have to ask you to use another email for the time being, if you have one available. If not, you can just put mine in.
Alexander, I'll be right addressing your question. Hold on a second. Let me try that. Oh, wait. Okay. Get the link. Let me just try this one more time. And if this doesn't work, I'll talk a little bit about Cluster API to address Alexander's question.
Yeah.
And then I think we should consider a rescheduling, since we probably will not have enough time. Hold on a second.
And just for everyone else in the audience, if this were to work, I need you guys to go into the same link, that dashboard.advantage.run in, and then use a different email, and it'll put you into a brand new account.
Let me see if this works. Although I'm actually inclined to think that that's a little bit too complicated for everybody. Well, hold on a second. Given time, because we only have about 20 minutes left.
Everyone's accounts is still available for another 13 hours. So even if you can't hit every single module today, with the link, they'll have enough time. So first, the first thing would be to turn off the AWS. So what I did was, when I started a new one, I turned off the AWS credentials first, and then put those scripted, and then it worked.
Okay, so turn off credentials.
Yes.
I know this is little for people to see, but it's just okay. Get the script. Run the script. So while I wait, so Cluster API is a project that is open source. And matter of fact, let me show you a few things while this is happening. So Cluster API, copy. And Cluster API has a bunch of different providers, okay? The one that we're using today is called the Cluster API AWS provider. If you go to this URL, you'll get to the Cluster API book, okay? It's a valuable resource for anybody that wants to learn.
It worked.
Okay. This. All right, perfect. Okay. Cluster API, and basically it's a project focused on exactly what we're talking about: declaratively configuring and provisioning and upgrading Kubernetes clusters. It's basically using the same technologies that the Kubernetes is using, and that we use with GitOps to actually handle the life cycle of the Kubernetes clusters themselves. So I'm gonna get a little bit further. I'm talking here to the people of Techstrong, because we might need to either reschedule or schedule a second session where we complete this workshop because of time constraints. Okay, but I'm gonna keep going. Musa is okay. Musa is asking how to turn off the credential. Okay, so you hit this little cogwheel up here in preferences in your IDE. You're gonna get this kind of scroll down. Oh, you're doing that. So thank you. I thought it was you.
You can keep talking about CapI. I'll type it out.
Okay. All right. So I'm gonna go through these motions real quick. Hold on a second. Just want to make sure that we're still able to talk to the cluster. No, I can't anymore. I can't use, if I use the, you really can't, you should not export your, the data that you got from, let's see. Yeah, do not paste the session token and access key and secret access key because that will break your access. And if you did, unset it. All right, so I'm going to copy it over. And I'm going to install Flux. If I look at the cluster, we'll see that there's nothing running. Okay, other than the basic services of the EKS service. Okay, I installed Flux. I'm going to export my GitHub token because we're going to bootstrap this cluster. I'm very quickly going to delete the repo that was created in the first attempt. 1 second, so that we all are in the same place. Okay. And I'm going to bootstrap the repository. Okay. I mean, I'm going to bootstrap the cluster against the repository using my GitHub account. That'd be called Workshop DevOps. We're doing basically the same thing again. This is generating all the different manifests that are going to be used to reconcile your cluster against this repo. And we're going to wait for Flux to be available and healthy. Okay. All right. So if we look at the cluster now, you'll see that we have a new Flux system namespace that is running our GitOps agents. These are the agents that are running in the cluster to keep it up to date. All right. Now, we're going to clone this repo that we just created. We're going to be working on its code. Okay. And we're going to go in there. I'm going to switch over to the next slide. As we had done in the previous iteration, in the previous attempt, we need to create a with GitOps values file. This is where we're going to configure the credentials. As I had mentioned, this is not something that you would do in production. In production, you would set it up with some federation against some identity provider. Here, we're just creating the values for an admin user. And we're going to create a source, okay, pointing to a Helm repo that we're going to use to install with GitOps. We're going to export this as a file in this repository, okay? So now you can see we have two new files with GitOps values and this with GitOps source that we just created. We're going to add those. We're going to commit those. I'm actually going to add my email, my name, okay, and I'm going to commit this. We're going to say I'm adding the with GitOps Helm repo. Okay. I'm going to push this. Since we're using an HTTP, what's it called, repository, you're going to need to authenticate. This is a whole lot simpler if you were using SSH, but for the sake of this demo, we can use HTTP. You can use your password, your GitHub token. Okay. Now, if we look at the cluster, you'll see that currently we likely don't have any Helm repositories. But what we just added to the cluster was our first Helm repository. All we did was push that manifest to the repo. GitOps is actually going to track this and pull the repo, the Git repository over time, every few seconds. And as soon as it identifies that there is a new file, a new manifest in there for a Helm repository, it's going to reconcile it. Oh, there it is. You see? It just added the GitOps repository to Flux system. And it pulled the latest revision from it. This will happen automatically because we've GitOps, Flux running in the cluster, and we just added a source from a Helm repository to it. Okay? So this is GitOps already working. Now we're going to install GitOps Helm release. So what we did is we added a repository. Now we need to install a Helm chart, quote unquote, which is what you would imperatively do by saying, Helm install. So going to do the same thing. We're going to create a Helm release, and this is going to again create a file for us in the file system, in the repo. If we look at what's in the repo now have this new Helm release, which is a manifest. It's a declaration. Okay. Hold on a second. Of a Helm release. You see, we're only working with declarations, and we're pushing those declarations to the cluster. We're going to commit this. Actually, we're going to add it. We're going to say we're adding the GitOps Helm release. I'm going to push this. Now let's watch what's happening in the cluster. Here that I'm just running Helm controller, customized notifications, and source controller, okay, in Flux system. These are the basic Flux components that we got there because we bootstrapped the cluster with Flux. Flux started tracking the repo, and you see how this just appeared now. Flux started tracking the repo, and we added a Helm repository additionally, and we added now a Helm release for GitOps, and now we have GitOps running, okay? As you can see, anything that I introduce to the repository, which evolves my desired state, is reflected, is reconciled in the cluster automatically by the agents running in the cluster, okay? So since we're short of time, I'm not going to expose the GitOps UI, and I'm probably going to request for this to be rerun so we can go over it again with more time. But I want to show you kind of like the real value of Cluster API. So now we have a cluster running, and we have GitOps and Flux running in that cluster. Okay. Now we're going to install Cluster API. This is another set of tools that you're going to use to bootstrap this cluster as your Cluster API management cluster. Okay. So you can just copy paste this as is. Hit enter, and now you're ready to bootstrap your management cluster. Now, do bear in mind, these instructions, don't follow them verbatim, because here I'm asking to export this secret key and ID and whatnot that likely will break things, okay? So don't use that. You should already have in your path, in your environment, a AWS region environment variable set. Maybe don't. See. No, we don't. So only do that. Only copy this first export so that we are in AWS East 1. That should be it. Don't do any of these because you're going to break your authentication of the Cloud9 ID. Now what we're going to do is we're going to bootstrap the cluster. Bootstrap the cluster. Now, let me kind of explain to you a little bit of what we're doing here, okay? Cluster API is a framework that has providers, okay? We're going to be using the AWS provider because we're going to be, since we're in AWS and we're in Cloud9 and we're doing all this within AWS, what we're going to be doing is we're going to creating an EC2-based Kubernetes cluster, okay, on EC2 instances. So each provider has kind of like their own set of different bootstrap requirements, right? Because you're going to need some underlying access rights and permissions and roles and whatnot in every target environment to be able to do things, okay? So For the AWS provider, we have cluster AWS ADM, which is the AWS version. Okay. This automates the process of creating the underlying kind of roles and permissions that cluster API is going to need to be able to create stuff in the cluster. Okay. If you go back to your AWS console and you go to a CloudFormation, you'll see that what this is actually doing is creating a CloudFormation stack. This happens outside of the scope of GitOps. This is just the cluster API provider setting up the underlying requirements for cluster API to operate. Okay. Now, for anybody interested, our enterprise product with GitOps Enterprise actually brings GitOps even to these different steps. Okay, so the whole idea is that everything down to the cluster API provisioning happens through GitOps. With our open source version, the actual creation of this cluster underlying IAM resources happens separately. Okay, you'll need to configure each provider, the underlying access components to each provider once, and you do that separately. So we're going to wait for this CloudFormation stack to be ready for us. As you'll see, it's creating a set of IAM roles and managed policies and different things that it's going to need for the agents running in the cluster to automatically create that cluster for us. Okay, so we're going to give this a few seconds. While we wait, I believe I was talking about cluster API. So there's numerous cluster API providers, and I have very good references. This cluster API, the cluster API book. This is actually managed by a SIG, a special interest group of Kubernetes. So this is actual upstream Kubernetes maintained. And it basically allows you to do that, manage the lifecycle of your clusters themselves using the Kubernetes kind of API and using Kubernetes style API. There's a whole bunch of different providers. The one that we're going to use today is called Kappa, and you'll find, so there's Kappa, which is the cluster API for AWS. There's CapZ, which is for Azure. There's a Cap something for all the different engines that infrastructure providers that I mentioned, right? So there's all sorts of providers that you can use, and the benefit is, again, for hybrid, which is kind of like where we all started this conversation, that you can use the same means to manage the life cycle of a cluster and to provision clusters using a common framework but different underlying providers. All right, so we've bootstrapped the necessary components in IAM to be able to have cluster API do things for us. We need to get we need to store that in a secret. What we're going to be using, the identity that we're going to be giving control the cluster API agents to do their things, and then we're going to initialize this provider within the cluster. Okay, this is going to install a few things in the cluster, and this is basically going to give us the capability to create other clusters using the AWS provider by pushing manifests that are using cluster API and AWS provider within our desired state repository. While we wait for this, let's create a new SSH key. We're going to need to pass that on. So let's switch over back to our AWS account, go to EC2, and create a new SSH key. And we're going to call it default, just because that's what's in the documentation. We're going to call it default, and we're going to download it. Okay. All right. Now we have a cluster ready to create other clusters. Okay. And if we look at what's running in the cluster now, you'll see that we have our Kappa controller, which is our cluster API AWS provider controller, as well as the CAPI controllers themselves, which is for bootstrapping and for control plane management, and other tools that CAPI will need to create our clusters. Okay. Now let's create our first cluster. All right. let's export this other variable, just this one, just actual 3 variables, not the region one, but the SSH key name, which we have default, and then the capacity of our nodes, okay? Export those 3 variables, and we're going to generate a cluster API manifest, okay, using cluster control. Again, what have we done now? We just added a file, okay? This file, we're going to modify. Again, everything that we do is just working with code, with manifests, descriptions, okay? This is our description of our cluster. As you can see here, there's a clear boundary between our cluster and the provider of that cluster. So this is generic. This can point to any infrastructure reference. This is a specific infrastructure references. And this is the kind of boundary, the decoupling of those 2 elements that I mentioned. Now, for this particular workshop, we want to make sure that we're not taking up a lot of resources, and we want to be fast. So we're going to modify this so that our AWS cluster is actually created on a VPC where only a single availability zone is going to be used. Give me 1 second. Only one VPC is going to be used, okay? So we're going to add this to our YAML. We're saying, you know, for AWS, I want a VPC where only one AZ is going to be taken. We're going to save this, okay? We're going to commit this to our repo. So we're going to add it. Adding our first cluster. We're going to push this over to the repo. All right. And now what you'll see happen is that a new cluster is going to start to be created. You can use cluster control to describe that cluster. Okay. You see it already started to happen. Here you can see all that it will do. Now, this is handling all the logic, all the actions that you would want to do to create that new cluster, that new environment. Matter of fact, it's going to create a VPC for you. It just created that. It's going to create the necessary subnets for your new cluster. It's going to create your route tables. It's going to create everything that you need to run an EKS cluster. Okay. Now, this is going to take a few minutes. This is also going to bring up the instances, NAG gateways, etc. So some of you might be asking, what if I don't want all that? What if I already have a VPC and there's already subnets and there's already all that stuff, right? So you can also configure that in your cluster API manifest. You can say, hey, you know what? I want to bring my own infrastructure. And I want to use an existing VPC and I want to use an existing set of subnets. You can control all that through your cluster manifest. And then the agents running in the cluster are going to take any necessary actions to reconcile them and to make that happen. Okay, this is going to take about 10 minutes, which actually brings us to basically the end of our allocated 2 hours. So I'm going to ask, are there any questions so far that anybody would want to cover? Okay, so what if you want to roll back your cluster? So part of what is in this instructions that you'll see is a roll forward in terms of version, okay? So it depends on where you are in your life cycle, right? And what you're doing. If you want to roll back a cluster, you basically, and you have purge enabled. So when you configure GitOps, you can define whether removing files from your desired state repository will eliminate those resources from your target environment. It's called purging, right? If you have purge enabled, you will effectively, by eliminating your cluster manifest, you are effectively going to destroy that cluster, right? It's going to eliminate the cluster as well. All right. So to answer, like, there's multiple ways to answer your question. There's, of course, the fact that since you're using Git, and let's say you eliminated a cluster by mistake, that is a point in time in your evolution of state. So if you need to roll back, then you go back to the commit where the cluster did still exist, right? And then that will bring your cluster back up because you're going back in time. You're going back to a version of your desired state where there was a cluster, right? That configuration likely will be pointing also to a repo where you had all your workloads defined. So once that cluster comes back up, it will look into a repo where there's a desired state stored that has a definition of all the workloads that it should run. So you will recover your state to a point in time where things existed, okay? So that talks in terms of configuration of your clusters and your workloads. It, of course, doesn't talk about data, okay? And that's something that I mentioned at some point. If you this, let's say you're using GitHub, right? And you go and delete your repository, you know, and then you destroy it. Then that is kind of outside of, I guess, the GitOps spectrum of things. That's just proper IT management practices, right? Like you really should have backups of your repositories. You should have proper access controls in place to avoid that type of thing from happening. You should have, since you're using Git and you're basically using this code-based flow for everything, you want to make sure that you're using pull requests that are validating what type of changes are being introduced in your desired state. You want to have proper authorization so that only certain people or automation can handle certain actions, such as merging. You want to know where you want to have purge enabled, where you want to have notifications occur when elements get deleted without purging them. So I think these are all the different components that would like be relevant to making sure that any type of destructive action is controlled, and this is applicable to everything, right? To your repo getting removed, to somebody manually destroying things in clusters. I think GitOps actually gives you a lot of guarantees that you have coverage to revert and overcome a lot of those challenges, but you still need to apply proper engineering practices, right, to other type of destructive action.
I'd like to also add in general CI/CD pipelines, separate from GitOps specific information for general backup plans. Your master plan should always include some form of version control, being able to roll back to different versions of a specific project you're working on. So in this case, Leo's working on a cluster, having versioning available on things you're pushing or pulling through Git control. So in case anyone were to ever ask you if this is part of your plan, you'd be able to just immediately say, of course. Having that as part of your backup plan is always essential.
Anybody other questions, please go ahead. Thank you, Zoe. All right, so I think this is going to take longer than we have available. First of all, I really want to thank everybody for your patience. I know it's not fun to watch two people troubleshooting stuff. That's what we do all day. Like the workshop should be different, right? It should work. But anyways, thank you for your patience. I hope what we've covered was valuable, but I do want to cover some more things that we couldn't get to today. So I'm gonna talk to the organizers of this event, and I really hope we'll be sending you an invite to kind of like a second iteration, a second session where we don't do presentation, where we don't do a deck, and we go straight into workshop and make it flow a whole lot better. Before we wrap up, I'd like to hold on a second. Where did that go? Give me 1 second. So this is what we went through. We'll share this with everybody. There's a few things that you can get to learn some more. There's a white paper called Best Practices for Hybrid Cloud Kubernetes. You can get it from that short link. Feel free to contact us for a demo of our enterprise product or of our products in general, and join us in other events. Again, please do expect an invite for another run, and we'll finish up. And thanks everybody for your patience. Cody, any parting words?
I do have just a couple of housekeeping notes before we close out. But Leo and Zohaib, thank you so much for jumping on today. I know things didn't quite work out the way that we had planned, but I think that our audience is still able to walk away with quite a bit of information learned. And I mean, every failure is going to be a learning experience. So it was, for me, it was really cool to see you guys go through the troubleshooting and actually see what that collaboration looks like in a real-time manner. So I'm at least walking away with that. But Leo and Zohaib, again, thank you both so much. We did record this webinar, this workshop. So we will be making it available shortly for anyone who does want to rewatch, to follow back along with those slides and jump back in through some of those beginning steps. And like Zohaib did reiterate in our chat, the accounts are available for the next 12 hours or so. So please do continue to play around in the clusters and make use of this workshop as much as you can. So we do have a couple of gift cards to give away. We have 4 $25 Amazon gift cards. Our first winner is Arnold L. Our second winner is Benedict B. Our third winner is Isabella M. Our fourth and final winner is Ahmed E. So congratulations to the 4 of you. Keep an eye on your inbox to claim your gift card. But if you don't receive an email, please check your spam folder. I'd like to thank AWS and Weaveworks for sponsoring today's webinar. And my final thanks will go to you, our audience. We appreciate you guys hanging out with us all day today and following along with this workshop. We do want to see you at an upcoming Techstrong Learning webinar, and we will also see what we can do to get this one a part 2 so we can finish what we started here today. On that note, I hope everyone has a great rest of your day. And
thanks, everybody.
We're going to go ahead and close out.
Thanks.
Bye, everyone.
Very much. Time to go mobile. Have a good day.
Bye.